Graduates of the Penn State Department of Meteorology and Atmospheric Science end up in all realms of the weather and climate enterprise, some of them conducting some groundbreaking research. We're pleased to be joined today with one of those individuals. He is a fellow graduate of the class of 2011. Please welcome Dr. Chris Slocum, who works for the NOAA Center for Satellite Applications and Research. Chris, welcome to Weather World.
It's great to be here. It's great to be back in Happy Valley.
Yeah, so this is your first time back in about 12 years, actually. Take us through your career journey post-Penn State.
Right, so while I was here at Penn State, I got the lucky chance to be able to intern in Boulder, Colorado at the Earth Systems Research Laboratory, which is part of NOAA. And I just fell in love with Colorado and wanted to go back to Colorado. No matter how I did it, I wanted to get there. So I ended up going to grad school at Colorado State University. And in working on my graduate work in atmospheric science, I focused on tropical cyclones in Colorado, and I just have stayed there. So I went from being in the department and graduating, and then switching over to a research scientist with the Cooperative Institute for Research in the Atmosphere. Some people know it as CIRA. They'll see our images out in the media in the wild. And then I transitioned over to a federal position with NOAA.
That's awesome. And so a lot of your research has been focused on tropical and satellite meteorology in Colorado, not a place where you'd really expect tropical research to be conducted. What made you kind of focus on that area?
So I always like to joke that I know how bad tropical cyclones are, and I want to be as far away as possible. So for us in Colorado, that usually pans out, although we do get precipitation from tropical cyclones that recurve, like this year with a storm off of California. We got that moisture too, ruined some of my camping. But usually, Colorado is a good place to be if you want to avoid hurricanes. On the research side, the department was actually founded by a tropical meteorologist. So the department's always had this history in the tropics, even though we're the furthest from the tropics as possible.
And you actually have had a hand in developing some of these satellite instruments to study the tropics. Talk a little bit about your work on those instruments.
Yeah, so what we do is we work with other parts of NESDIS or other parts of NOAA who develop the satellites in partnership with NASA, and then we create products off of the imagery. So a lot of people just see the image and they're gorgeous, but you actually want to use something from that image to make a forecast, and you want to derive products from that imagery and tie it in with model data. So you need to kind of couple those things to make it actually useful for folks.
I was looking through some of your publications. You've got many of them. Great to see. Two topics really come up a lot, especially in some of your most recent publications, and topics that we've even talked about here on Weather World: rapid intensification and eye wall replacement. How did you kind of focus on some of those areas, and what are some of your discoveries?
That's a great question. So for tropical cyclones, we have a good idea of how they intensify, and we have a good handle on the track, and those forecasts are becoming really great. But there's these points in the forecast where there's a lot of challenges. And so then from my graduate work to present, we've been trying to focus on these pain points in the forecast. So if you think about rapid intensification, it's really not a novel physical process for a tropical cyclone. It's really a tropical cyclone doing what a tropical cyclone wants to do, and that is intensify and become a really intense storm. And it's that fringe forecast that really impacts humans. And so we want to know, okay, if the storm is going to rapidly intensify, do we have enough time to evacuate people? Because it does change the hazards people feel. Same is true with eye wall replacement cycles. So for those who aren't familiar, that's when you have the core thunderstorms that make the eye wall, and that gets replaced by another circular pattern of thunderstorms. And the storm will change its structure in that process. So it might become bigger, and then that means it can push more water into the coast when it makes landfall. So we want to know these hazards, and those parts of the forecast are still a challenge, and that's where we really want to have satellite data help fill the gap and kind of close that time window to make those accurate forecasts.
Another area that you have spent a lot of time in researching involves what we call machine learning, or AI, artificial intelligence. Talk about how that is really becoming a game changer for forecasting.
Yes, one thing that most people don't realize is that the Weather Service and also NESDIS, they've been using machine learning since the 80s. It was more in that classic form of machine learning where it's just a basic relationship and you can only handle a linear relationship where things are very well structured and you can understand it, but you don't understand what's that nonlinear component where it's very random and chaotic. What is that going to be, that random trigger? And so from those classic machine learning techniques, we can advance and use some of these more advanced techniques that can maybe capture that trigger point for something like rapid intensification or eye wall replacement. And that's where the game changer element can be. Although we're still very early on in applying artificial intelligence into the entire workflow process within NOAA, and that's something that we really need to understand better.
Absolutely. One of the great things is you work with some of our graduates here from Penn State out in Colorado. What's it been like, having that experience now, now with the PhD in your field, an expert in many areas, working with the next generation of researchers?
Yes, it's been great. I've had undergrads who've come out and interned with me, or I've had other undergrads from other universities who've come here for graduate work. And it's been really fun to see that foundation, see some of the same faculty, although that's beginning to change as the faculty evolves, and hear some of the horror stories about courses that are here and have those shared experiences. And then it really helps form that foundation for the research, the exciting things that we do. And it's a lot of fun having that connection to State College and Penn State and then be able to do really exciting work with them.
And real quick, we're almost out of time, Chris, but we always like to ask, favorite memory about your time at Penn State?
Well, the ice cream ranks really high up there, but for me, my favorite memories are being at Irvin Hall, which is the interest house for the College of Earth and Mineral Sciences, and that was always a great experience, and both of us were there, so we have some good shared stories.
We actually lived next door to each other for a couple of years. So, Chris, it was really great to have you back in Happy Valley and here on Weather World. We appreciate it, and that will do it for our Weather Water Cooler series. We'll be back in just a moment with more.